Keeprite is a world leader in refrigeration. We're a manufacturer of refrigeration product. We produce all the componentry that goes into commercial refrigeration.
Evaporator coils, condensing units, air-cooled condensers, and we're working on new projects, new technology every day of the week.
Keeprite's been a company with long-term roots and history, and we developed a team of people around it that are dedicated and hardworking. Keeprite is a technology leader, constantly evolving and strengthening.
Keeprite is on the leading edge of technology. Keeprite Engineering Department is comprised of degreed engineers, walk-in simulators, environmental chambers, and calorimeters. Our testing is extensive, and that allows us to deliver the highest quality equipment around the world.
The end user's need is changing on a day-to-day basis. Recognizing that, we understand the true need for flexibility. We're incorporating that kind of philosophy from start to finish, from the design of our product all the way through to the supply of our componentry.
We can make anything cold, and it doesn't matter if it's a small behind-the-bar reach-in refrigerator or it's a 1.5 million square feet frozen food warehouse. There's nothing that requires cold that we can't do.
A lot of people want to boil refrigeration down to being something as simplistic as air conditioning, but there's an awful lot of elements to be considered when you're designing a refrigeration system. It's the environment that it's going to work in. It's the support that it needs to be running day in, day out effectively. There's the need for energy efficiency, and we must incorporate every bit of today's technology that's going to meet those needs.
Our industry gives out 8 awards annually. We received 2 of them last year for Energy Awards for innovative new designs.
Energy efficiency and environmental demands are the biggest concern today. Keeprite is taking those concerns and demands into every research and development project we're doing.
Since I started with this company, we've released more new products and modifications of existing products than our 2 major competitors combined.
We have redeveloped the business and put the things in place that we need to really satisfy, really take our product to the customer.
We've developed pretty much a whole new product line. Every product has been through engineering. We're continually doing R&D. We're continually coming out with new products.
The average experience of our employees is 18 to 20 years right now in this facility. I have no turnover rate here of employees because they like this place. They enjoy this place. They're part of the product that we put out every day. We're enjoying tremendous success, and we're growing because of the quality here at Keeprite.
I'm proud to be part of Keeprite Refrigeration because I believe we have good management leadership and a good quality product that we all take pride in.
What makes Keeprite Refrigeration the market share leader in Canada and probably the company growing the fastest in the United States in our industry is the passion behind the people.
I'm extremely proud of the people in Keeprite Refrigeration. They're passionate, they have desire to take us to the next level, just to truly satisfy that customer.
All right, and ESP Plus is a very fitting name for the controller, as it basically has the ability to learn and adapt to what's happening in the space. So just showing you a short little video here just to kind of give you an idea of what this controller looks like. So you can see that basically there's a display that's mounted on the front of the evaporator, and then the control board, electronic expansion valve, and the liquid line solenoid valve are all factory installed inside of the evaporator. So, think of the ESP Plus, it's really a complete package. All right, so it's not just the controller, it's the evaporator, the electronic expansion valve, and the liquid line solenoid valve that make it that complete package. So it's an intuitive evaporator control technology, and it's designed to save energy and optimize the performance inside the box. So we're doing that through the use of the controller, which has all kinds of adaptive control algorithms in it, the electronic expansion valve. And what's really neat about this controller and other controllers on the market is they have something called adaptive defrost control. You might also have heard the term demand defrost. So it's a new way of doing defrost where you're not relying on a time clock anymore. The controller is actually monitoring the evaporator, and it's deciding when it's going to go into a defrost cycle and how long that defrost cycle is going to take. So huge advantage when doing that, and energy savings. So we're going to talk a lot about that in the presentation. You've got precise temperature control because of the electronic controller, and that really helps in the shelf life of the product and keeping its quality. You've got remote monitoring and communications, which, you look at all of the devices now in the industry that are smart devices, monitoring and communications is all part of those type of controllers. Very easy to install. All right, so this is really going to reduce your installation time when you're putting one of these controllers in. Very simple to set up. So we're going to go through how it's simplified and how easy it is to set up this controller. All right, so the ESP Plus, it's an intuitive evaporator control technology. All right, so it's using this microprocessor control board, and it's taking a look at what the space conditions are doing. It's monitoring the coil temperature. All right, so you see some sensors there on the right-hand side. And based on the information or feedback it's getting from these sensors, it's able to determine how it's going to refrigerate that space and when it's going to go into a defrost cycle. All right, so you've got the ability to do remote monitoring. And if you're on site, it's very easy to get into the controller and go through the settings. You see this little front display here. All right, so you go to that display, and that can take you through all your settings there. Now, you're going to see some different components than what you would typically see on your standard systems in the field there. So normally you see a thermal expansion valve and just a regular electromechanical thermostat. So by replacing it with this package here, again, you're going to see really precise control and a lot of savings. So that's a big advantage for the end user, and having that improved product shelf life is big for them. But for you guys, or for an installer, the big thing is being able to reduce your installation time and having that remote monitoring capability so that you can troubleshoot it remotely. All right, so the other nice thing is you don't have to be in the box. If it's a freezer, you don't have to be in there, going through the settings to set this up. You can be out in your truck, or you can be out somewhere in the building where it's warm doing all those settings. So the SP Plus, it controls your box temperature. All right, it allows you to do a very tight temperature control. So you can actually set this up in 0.1 degree Fahrenheit increments. So if you want to keep a box at, say, 37.5 degrees Fahrenheit, you can dial it into 37.5. Default setting would be 1 degree Fahrenheit. So if I'm at 38.5 degrees Fahrenheit, I'm going to bring the refrigeration system on. Now, if you compare that to your conventional electromechanical stat, you're working on a dead band of maybe 35 to 40. So it's going to cut into refrigeration mode at 40, and it's going to cut out once that temperature drops down to 35. So that box temperature is kind of fluctuating as to where it's being maintained. So it's not the best scenario for the product, and that's why this ESP Plus just gives you better control. Now, it's also going to control your superheat. So an electronic expansion valve, it allows you to keep a really constant superheat no matter what the conditions are outside. So, if you've got minus 20 in the wintertime, or you've got a designed summer day at 95 ambient, that controller is going to maintain a very efficient profile that's going to maintain a very constant superheat. And it's also good for the compressor. It's more stable operation, and it's going to protect it from floodback. Now, it's also going to control your defrost heaters. Something that's really different with this adaptive defrost or demand defrost sequence is that we cycle the heaters on and off during a defrost cycle. Right, your conventional system, it's keeping those heaters on 100% of the time during the defrost cycle. And the problem with doing that is that you actually put a lot of that heat from the element right out into the refrigerated space, which you ultimately have to take and refrigerate back down to temperature. So by not putting as much heat in there, it's a great saver. Now, the controller is also going to look after defrost initiation and defrost termination. All right, so it's going to be monitoring that coil, and we're going to be talking about how it does that. But it's going to know when to go into a defrost cycle and how long it's going to take, versus just using a time clock that's set for 3 or 4 defrost cycles per day. So, by able to do the monitoring of the coil with this adaptive feature, you can actually take your defrost cycles from maybe happening 4 times or more a day to maybe only happening once a day. The other thing it's going to control is your evaporator fan motors. So we're all using ECM fan motors now on the evaporators, and we have a 2-speed ECM motor as standard. So on refrigeration mode, it's running at high speed. When refrigeration is satisfied, that's when it goes to its low speed setting. So that's all done through this controller. It knows when to go into which speed. If you're doing a variable fan speed evaporator, then you would traditionally have a secondary controller to control that fan speed, but the ESP Plus controller will actually control your variable speed operation as well. Okay, so here's what it's going to eliminate, and this is why it's going to save you so much time when you're setting up the system. So no longer will you have a time clock, right? The ESP Plus is doing the monitoring and doing that adaptive defrost feature. So time clock's gone. You don't have a traditional electromechanical stat because the ESP Plus is now your thermostat as well. And it gets rid of those clicks-on sensors for your fan delay and defrost termination. So it has its own coil temperature sensor and its own algorithms built in that are going to be able to do all this function that we're talking about here, that we're removing components that would traditionally do this. So you can see this is going to save you a lot of time. You don't have to install these. You don't have to set up all these additional accessories. So another way of looking at it, so on the left-hand side there, you see our conventional system, right, with our time clock, our thermal expansion valve, clicks-on sensors, and mechanical stat, and a liquid line solenoid valve. All right, so that's what we're all used to seeing out there. But what we're seeing now is you're going to have the ESP Plus controller with an electronic expansion valve, and we're still going to use a liquid line solenoid valve. But you can see there's some reduced complexity there, not as many components. So we're combining the function of your thermostat, your defrost time clock, your termination sensors, your fan delay sensor, and we're going to give you that precise flow of refrigerant with the EV controller. So we're really reducing the complexity of the system. The other thing we're doing is there is no interconnecting wires now between the condensing unit and the evaporator. All right, so that saves you money with the electrician, not having to run that extra wire. All of the components that you see there on the right-hand side, they all come factory installed and wired. So don't have to do that anymore. Minimal field wiring. So basically you're going to run your power wires to the evaporator, to your condensing unit, and you might have a category 5 cable if you're going to do remote monitoring. So that's basically it for the wiring. Startup is very effortless. Basically, the controller is cutting a lot of the time down in terms of what you're installing and actual settings that you have to go through. So we'll go through what those settings are, and you'll see how quick and easy it is to do. And for troubleshooting, it's very simple. Controller has onboard diagnostics. It gives you alarm conditions so you can troubleshoot it and see what's going on with the system. So I'm a visual person. So again, just to kind of give you a summary of what we've been talking about thus far, we're really reducing the complexity. You see on the left-hand side of the screen there, that's your conventional system that you would typically see out in the field. Right, you've got your two pipes going between the evaporator and condensing unit. You've typically got 5 control wires, and then inside the condensing unit there, you would have your defrost kit, and then you would have your components on the evaporator, your thermostat, and your thermal expansion valve, and other sensors there. So now we're going from this to the right-hand side, where you can see you've got a condensing unit, no longer a defrost kit in there, and you've got your liquid and suction line going to your evaporator, which has your controller. So it's all, very simplified as to what you do on an installation, not as much to do at all. And in terms of setting it up, again, 2 pipes, your power wire, the additional category 5 cable if you're going to do remote monitoring, and no wire between that condensing unit and evaporator. So really saving on installation time. You'll find that when you go into the controller to go for your settings after you've got it installed, we've already got it factory programmed for you. So when you place that order with the distributor, and say you're ordering an evaporator for a cooler, the default setting would be 35 degrees Fahrenheit, and on a freezer, it would be a default setting of -10 for the set point. Now, if you have a different temperature than that, that can be changed through the keypad located on the front of the display. And on that display, basically all you've got is 2 buttons that go through the set point menus. And there's really only 3 settings you really have to go through on this controller. So if I hit push the enter button for 3 seconds and hold it, that takes me into what's called the basic set point menu. And in here, this is where my room temperature, my refrigerant, and my defrost type is displayed. All right, so we're going to set that up at the factory depending on what the order is. But if you got it on site and you want to change something, here's where you would go in and change those parameters. So very easy to do. There is an advanced menu set point. This menu is more for fine tuning to a certain application. So most applications you would not be going into the setting at all. But basically in here, this does have your superheat setting. So if you wanted to change the superheat setting, our default setting is 8 degrees Fahrenheit. That's going to cover most applications out there. But that's where you would change that setting. So, if you're going to go into that setting, I would advise you to call into our tech support team, and they can kind of walk you through what you would change in there for your application if that was required. So what's nice on this front display on the evaporator, you can kind of quickly see what the status is. You'll also see there's a way to put it into a manual defrost mode here. It says if you hold down the enter and the down arrow, you go into a manual defrost mode. You're also going to notice that on the right-hand side of the display, there's 3 LEDs there. So the top LED, if it turns red, that means you've got a critical alarm and the system's not going to be operating. If this middle LED lights up, it's going to be a yellow color, and that basically means that you've got a non-critical alarm. System's still going to operate, but there's something there that you've got to attend to. And this bottom LED, it turns green, and that means your system's operating. There's no issues going on. So you can see the idea behind this. Somebody can walk into that freezer or refrigerated space, and they can quickly take a look at this controller to see what mode it's in. Does it have any alarms? What's going on with the system here? So you're going to see 15 to 20% energy savings over a properly commissioned system with electromechanical controls. And really, those savings are coming from that adaptive demand defrost feature. That's really saving you a lot of energy right there. But it's also giving you that added benefit of more precise temperature in the box for the customer, and that's going to allow better product quality. And then the other great feature of this controller is having that electronic expansion valve to have a stable superheat and just give you more efficient operation. So we still put a liquid line solenoid valve on there again, just in case you've got a power failure. We want to stop that flow of refrigerant. So we use that, that valve. All right, so now we're going to get a little more into the meat of how this controller works and why it's so more efficient and beneficial to use. So before we kind of go into the theory of it, let's talk a little bit about evaporators and frost buildup and what happens to your capacity. So, you know, ideally we want an evaporator coil that's free from frost or ice buildup, because as we build up frost on a coil, that means we're going to start losing heat transfer, and ultimately that means we're going to lose efficiency of that system. All right, so when evaporator's running in refrigeration mode, initially you're going to start getting a little bit of frost buildup on that coil. And that first bit of frost that builds up, it's actually going to give you a bit of a benefit. It actually increases the surface area of that coil slightly so that you actually pick up a little more efficiency, but that's only short-lived. All right, as you start building up frost on that coil, it's going to start acting as insulating the coil like a blanket. So it's going to retard heat transfer to the coil. And as that happens, your suction temperature is going to keep dropping to try and maintain that space temperature. So you're going to build up frost more rapidly when that suction temperature starts dropping more. So when we do that, we start losing our heat transfer. You know, we start getting that real heavy frost and ice buildup, and it takes a long time to defrost that as well once you've got a coil that's really built up with frost. What the ESP Plus does is it's actually monitoring the coil. All right, so it's doing two things. Okay, it's going to look at the amount of frost that's being built on the coil, and it's going to be able to adapt. So if it sees that maybe because the door's being left to the box open more often, you're getting more infiltration air, you're getting more frost buildup on that coil, it's going to see that, and it's going to know it's going to have to do a defrost sooner. So the other thing it's doing is it's monitoring the system, and it's only going to call for a defrost when it's necessary. So what it's doing is when it's looking at the coil temperature, it knows that once it gets to a certain temperature, it's got a certain amount of frost buildup on there, and it needs to initiate a defrost cycle. So it's going to try and maintain about 90% efficiency, if you will. Right? So if it sees a 10% capacity loss, that's where it's going to kick into a defrost mode. So basically what happens on the evaporator is once you power it up for the first time, it goes through a sequence where it does a refrigeration cycle, it stops, it does a defrost cycle, and then it repeats, okay? And what it's doing while this is happening is it's setting up a profile of that evaporator to see how it operates in the space. Once it has that profile and you go back into refrigeration mode, it's going to compare the return air temperature and the coil temperature to that profile and understand what it needs to do in terms of defrost cycles. So huge advantages to doing that. That's going to allow it to only defrost when you really need to. And it's going to have the ability to adapt to changes in the space. So again, I mentioned the door maybe being left open to the box, more infiltration air. Maybe you've got a lot of product coming in at a warmer temperature than you would typically see. It's going to see that and it's going to react to it. So, you know, traditional versus adaptive defrost. So time-based defrost, it's set up for maybe 3 to 4 cycles typically a day. And it may not need that, right? So the other thing it does is it brings the heater on 100% during the whole defrost cycle, and that puts a lot of heat back into the space. That also adds to something called the fogging effect. So if you warm the coil up too much, you start getting steam, and that goes out into the refrigerated space. And you'll see sometimes you walk into a refrigerated box and there's, you know, stalactites of ice cycles hanging from the ceiling. The boxes of products all covered in ice, and that's from this fogging effect that you get. So the other issue is now you've put all that additional heat into the space, which you ultimately have to refrigerate out. So it takes longer to pull down the set point. So you're using more energy to refrigerate that space. So instead of supplying power to the defrost heaters for the whole cycle, we actually cycle the heaters with this controller. So basically the coil temperature sensor, it's monitoring the temperature of that coil. Once it gets to a certain point, it says, okay, let's turn the heaters off. Let's let that heat dissipate into the coil. We've got enough there. And then once the temperature starts dropping again, it'll turn the heater on. So it'll do this many times during a defrost cycle. And it will end up going back into a refrigeration mode kind of in a similar time that you would see in a traditional defrost cycle. But it's going to use up to 40% less energy. And in addition to creating the fogging effect, which traditional defrost methods cause, they also waste 80% of the heat that they've generated is going right back into that refrigerated space. So the ESP Plus, by cycling the heaters, is going to reduce that down to 20%. So this kind of really sums up why the adaptive defrost feature is far superior to time defrost. So what you're looking at here, this is a graph where we're comparing temperatures. The blue temperatures there, the lines that are blue, are your coil temperatures. And I don't know if you can kind of see it there on the screen. There's these green temperatures here are your room temperature. So we're comparing the temperature on the y-axis versus time on the x-axis here. So what we did is we ran an evaporator for a month's period of time. The first half of that month, the first 16 days, we ran it with a time defrost sequence. And you can see all these blue spikes here. These are your defrost cycles that are happening. All right, so after the 16 days, we switched over to adaptive. And what you're seeing here is that there's a lot fewer defrost cycles going on. And the other thing you notice here is that the coil temperature is never getting near as warm as it is when it's time defrost, again, because of that cycling feature on the heater. So right there really shows you where the savings are here. So way less defrost cycles here and way less temperature spikes. So depending on your application, this could result in up to 86% fewer defrost cycles, right, which is ultimately going to give you better system performance. It's going to give you energy savings, and it's going to give you better product quality. Right, so it is far superior to doing time defrost. So you get the benefits of using electronic expansion valves. So electronic expansion valves are not refrigerant specific, which is a nice benefit. So if you want to change the refrigerant on the system you've got, or you decide to put a different refrigerant in when you're installing it, there's no issue there. You'll find that fewer valves cover a wider range of capacity versus a thermal expansion valve. All right, so you're going to find that these evaporators with ESP Plus have a lot fewer valve selections that you have to worry about carrying on your truck if you're keeping replacement parts. And the electronic expansion valve, it's going to adapt to a wider range of conditions. So we'll talk about that a little bit more. It's going to give you stable superheat and full capacity at lower head pressures. So, you know, if you're minus 20 degrees Fahrenheit in the wintertime there, you've got lower head pressures running, it's going to be able to adapt to that. So overall, you're going to get better control for lower average superheats. So, you know, when you're setting up the ESP Plus controller, because you've got the electronic expansion valve, the ESP Plus controller is driving that valve, and it's already set to 8 degrees Fahrenheit. So you don't have to do the setup which you would normally do on a thermal expansion valve, where you're taking temperature readings and pressure readings and adjusting that valve until you get to the superheat you want. So we like to call it set it and forget it. You've got 8 degrees Fahrenheit superheat into the controller. You don't need to worry about changing that. So again, electronic expansion valve, it's going to work better versus a thermal expansion valve across a wider range of temperatures or pressures. All right, so here we're comparing unit efficiency versus outside temperature. So when we size the valve for the normal operating condition the box sees, you can see a thermal expansion valve or an electronic expansion valve operate very well. But as those temperatures start to deviate from that point, the electromechanical or thermal expansion valve doesn't necessarily react as well and is not as efficient over the range. So electronic expansion valve you'll see is a lot more stable over the course of the different temperatures and pressures it's going to see through the seasons of the year. So again, with electronic expansion valve, they react a lot quicker than a thermal expansion valve when it comes to when the refrigeration mode comes on and you've got a load that's been put in that box. They will open up quicker, allow refrigerant to flow in, and bring that temperature down quicker. Right, so you can kind of see here, we're comparing that if you had a thermal or mechanical expansion valve running here for a while, it kind of hunts. It's trying to find that sweet spot to keep the superheat. And then once you switch to an electronic expansion valve, it'll initially go full open and then fully close and then start finding its throttle point to maintain that superheat where it should be. And you'll find that your condensing pressure and your evaporator pressure are going to be more constant with the electronic expansion valve. The one thing that the ESP Plus actually does takes us a little bit step further. It looks at history. So it looks at where that valve is normally positioned when it's in the refrigeration mode. And when it starts into a new refrigeration cycle, it starts at that point. So if it finds that most of the time it's running at 60% open, then once it goes back into refrigeration mode, that's where it starts its throttling from. Right? So it starts at 60%, adjusts from there, and that usually means it's closer to finding that sweet spot. Right? So advantages, again, you're going to have quicker pull down time, you're going to save energy, better temperature control, which is going to improve your product integrity, which is key in refrigeration. Another great feature of this controller is something called bonding. So when you've got multiple evaporators in space, you can actually connect them together so they're going to act as one control. Right? So you can synchronize up to 8 controllers or 8 evaporators that are on one condensing unit so that they work together. The other thing you can do is this has the ability to do lead lag control. So what you would do is you would pair your evaporators if you had 2 different systems, 2 different condensing units. You would take those evaporators, pair them together, bond them together, and then what they do is they lead lag their operation based on runtime hours, or if you want it so that one refrigerates, one's off, then it goes to refrigerate and off, and they switch back and forth. All right, so you no longer need that additional lead lag panel. The other thing you can do is you can set up how you're going to control the temperature. Are you going to control to the average space temperature sensor, or are you going to look at the warmest sensor on those controllers to control the box temperature to? The other thing it'll allow you to do is defrost your, or synchronize your defrost cycles. So if you've got 2 or more evaporators in that space, one comes out of defrost sooner than the other ones, then it can wait until the other ones are finished defrosting before they all go back into refrigeration mode. So that way you don't have them fighting each other. And the other thing it does is if you lose, say, one of the control boards, or you lose one of the return air temperature sensors on one of the controllers in the network, then it will use the information being broadcast from those other controllers to keep that evaporator running until it's fixed. Right? So the bonding feature, it really gives you some built-in redundancy, and it really maximizes your uptime so that you don't have you don't want downtime in a refrigeration application. You want that customer throwing out product. So remote monitoring, there's some different ways of doing this, but basically all you're doing to do remote monitoring is you're connecting the controller to the World Wide Web. So what would typically happen on a job site is you would plug this controller into the customer's computer network, right? Their local area network. And once you do that, Then you have access to that controller through different means, and that allows you to look at system status. You can put something on there like a door switch, that's an option, and you can see whether that door is open or closed. You can look at diagnostic info. You can remotely go on and you can change your set points. You can look at alarm conditions, control the system operations. So a lot of things you can see off this controller. And it's important to note anything that you're seeing on that controller is in real time. There's no lag. So when you're looking at it, you're seeing the temperature that it's at that moment. So again, typically you're going to connect this to the customer's local area network. You're just going to use a category 5 cable, and then you're going to plug that into the board, back into the customer's network switch or router, whatever they've got on site. And again, this is a free, easy way to set it up. There's no extra cost. You're just running a cable. The other way to do it is you could connect it directly to your laptop if you wanted to do that. And that works very well as well. It's a free service. There's other methods of doing it. You can connect to a wide area network and have a remote monitoring service look after monitoring those controllers. That's at an additional charge. And then there's also things called a Wi-Fi service tool that gives you a hotspot so that you go in with your tablet or your smartphone and you can connect to the controller and make the changes from there. So very easy to set up. You don't have to be an IT guy to do this. Basically, you go in, connect the ESP Plus to the router with your Ethernet cable. You have to go into the control settings and enable something called DHCP. And you type in the IP address. So the IP address is stamped on the board of every ESP Plus controller. And that IP address, all you're going to do is type that into a web browser on a computer or a smart device. And once you've done that, that's going to take you to a home page, or which we call our sample dashboard here. And on this page, so this one here that you're looking at is our home page. So it has all of our refrigeration parameters here. So I can take a look at, is this thing in refrigeration mode? Is it in defrost? I can see my room temperature, my coil temperature. Is my compressor relay energized? My evaporator fan or my defrost relay? I've got auxiliary inputs I can use. So there's 3 auxiliary inputs. So I could put a door switch on there. I could put a secondary temperature sensor if I wanted to do just a backup sensor to see what's happening in the space. I can also monitor my superheat, my suction pressure, suction temperature. I can even see my valve position because it's an electronic expansion valve. So you can see there's a lot of great information right here on this page. It'll show you if there's any alarm conditions here on the right-hand side of the screen. So a lot of good information here to help you kind of go through and troubleshoot a system if you have to. Down here at the bottom, you've got a settings page. So the one thing I can do once this thing's connected to the internet, I can put in my cell phone number and my email address. And if this controller has an issue, it can send an alarm condition either by text or by email to you to say that there's an issue. So that would be done in the settings tab here. The network tab, that's if you're setting up that bonding feature. Set points, instead of using the front display on the evaporator, you can actually go in and have a window that's got pull down menus so that you can put in your box temperature, your defrost and refrigerant types. Some people prefer that because it's a little bit easier to look at and they're used to doing it on a computer screen. And there's also a graphs tab. On the graphs tab, you guys will remember that slide I showed you where they were comparing the time defrost versus the adaptive defrost, and we were looking at coil temperature and the room temperature. So that same graph, it resides in this controller, and you can look at that over a 12-hour or 24-hour period to see what is going on in the box temperature-wise. Also in there, there's a place where you can click and you can actually download an Excel file that logs all of the points you're seeing here on the home page. It logs the points every 10 minutes. So now you've got them in a table format, which can help you troubleshoot the system, right? So actually had a customer had one of these on a convenience store, and the owner from the convenience store called him and said, you know what, there's something wrong with the refrigeration system. It's not keeping up in temperature. So he went on and he took a look at what the system was doing, and they'd put a door switch on that box, and he could see that somebody had left the door open, and that's why that box wasn't staying at temperature. So it's a really powerful tool. You can really see a lot from here and help diagnose an issue pretty quickly. So it's available on most of our evaporator lines. You know, this is applicable to whether you're doing a little box in a restaurant or a store, you know, right up to something you might see in a warehouse application with our higher profile evaporators. It works in all those applications. So benefits to the contractors and owners. So we talked about the 15 to 20% energy savings over a properly set up system that would have electromechanical controls. Again, that's coming from that adaptive demand feature. That's where you're getting the big energy savings. Remote monitoring and system control. You know, that's huge this day and age where everybody has, you know, information at their fingertips and wants to be able to see what the system's doing. So it can really minimize the downtime for the customer, and that's really important when you're talking about a refrigeration application and you don't want a customer throwing out their product. Very friendly user interface. You know, you see that display there, you can quickly look at it and you can see what mode the system's in, if it's got any alarms or what's going on there. Precise temperature control. So we talked about how you can set up the deadband there. So it's like 0.1 degree Fahrenheit increments, defaults 1 degree Fahrenheit, so that you're bringing that refrigeration mode on quicker and not letting the temperature spike, which can be detrimental to certain products. You want to keep them at a very constant temperature, right? So you can improve that shelf life. And you've got the 32-day history stored locally on the controller. So again, that's on that graphs tab setting, where you can download the points that are logged every 10 minutes. So that's saved for 32 days. And basically having that graph or table, and you have the diagnostic modes where you can cycle the relays for the compressor, your defrost heater and fans. There's different ways you can look at troubleshooting that equipment quickly. And you can also see alarms. So if you see an alarm that's on there, you kind of have a better idea of what to look for first. So it can really save you time on troubleshooting the system. Quick, simple installation. Again, you know, you got no wiring between the condensing unit and the evaporator anymore. So that's a big saver there. You're going to run your liquid line, your suction line, your power wire, a remote monitoring line if you want to connect it, and you're basically done. You go through the settings. They're usually already set for you. 3 settings, right? You got your refrigerant, your box temperature, and your defrost type. You just got to make sure those are correct. Improved evaporator performance by minimizing excess of frost on the evaporator. So again, we talked about how this controller monitors the coil and makes sure that it's not building up a large amount of frost on there. You know, it's going to take longer to defrost, and I mean you're not being as efficient as transferring heat. So great feature there. It's going to eliminate ice buildup on the surfaces and product. Again, you're getting rid of steaming that coil because you're cycling the heaters on and off. And we often find that this will solve issues in boxes where they've had that ice up issue in there with ice forming on the surfaces and on the product. So there's an energy savings with reduction in the number of defrost cycles. So again, because you're not doing time defrost, you're only defrosting when you have to, and as long as you need to. You're not running that cycle until, you know, you're terminating on temperature or time. You're really saving a lot of energy there. So the other thing, again, you've got the improved system diagnostics through advanced alarm notification and text email. You know, being able to know that you've got an issue with your customer's box right away, as opposed to waiting until, you know, they go in the morning and the box is very warm and they're throwing out product, it's a huge feature to have. So you're going to see a lot more of these controllers out in the field. They're becoming more and more popular these days. You're going to see a lot of the chains are starting to use these controllers or have been using them in the past. But as you can see, there's a lot of advantages to them. You know, the energy savings, the improved product integrity, that the fact that it's prepackaged and it's already readily installed, and all you got to do is set it up. It's really going to save you guys a lot of time out in the field. You know, keep in mind that adaptive defrost control feature. It's going to really reduce your defrost cycles and give you the best efficiency in that box. You know, remote display on there, very easy to use. Gives you a quick way of going into the box and see what's going on with the system. You know, am I on alarm condition? I'm in refrigeration mode, what's going on there? The electronic expansion valve, again, that's a key feature of this controller. It's not refrigerant specific and it's very efficient over a wide range of conditions. And we got the liquid line solenoid valve on there to give you peace of mind. So if you lose power, you're not going to be flooding the evaporator with refrigerants. So, you know, it's really the complete package, and it's gonna be something you see more and more in the future.